Good morning and welcome to today's CLC's lecture, Beyond Administrative Delimitations, Uncovering Patterns Using Complexity Science. My name is Yixuan and I will be your MC for today. The CLC lecture series is organized by the Center for Livable Cities as part of our mission to distill, create, and share knowledge on livable and sustainable cities. Today, we are delighted to have speaker Dr. Elsa Arcaute, Associate Professor from the Center for Advanced Spatial Analysis. In this lecture, she will be sharing on how to construct the territorial organization of the space beyond administrative delimitations. This refers to the way people interact and share a sense of community given by the connectivity of the space. We will see how this methodology can bring insights into the organization of 11th century Britain using data from the older census in Europe. The format for today's lecture will start off with a presentation by Dr. Elsa, followed by panel discussion and Q&A session with the audience. The discussion and Q&A session will be moderated by Mr. Huang Zhongwen, Director of the Digital Planning Lab for Urban Redevelopment Authority. Kindly hold all questions till the Q&A session. Thank you. With this, let us start the session by inviting Dr. Elsa on stage. Dr. Elsa, please.
Well, thank you very much for inviting me today to speak about complexity science in urban spaces. And so I'm going to start actually with a motivation of what are the main ingredients that we need in order to understand cities within complexity, right? So of course, the first thing is people, right? Without the people, we don't have cities, and so one of the main key ingredients is the demographic composition. So you have the demographic composition, but then once you have that, you need to be able to make the proper measurements in order to be able to measure things like inequality. And sometimes these are the main things that are the main issue for complexity science. How to really bring in indices that make sense, are coherent among many different systems. The next key ingredient is movement. So one needs to think about cities as places of connectivity. And so this is where networks come into place, right? The interactions, so the networks within cities are not the one unique single definitions for all cities. Depending on the sort of problem that you need to look about, is how you're going to be connecting one place to another, or people to places, or people between places, and so forth, okay? So in this sense, networks need to be thought about in a broader term. You are going to construct your networks depending on the problem that you need to solve. The next thing is that, okay, so I have the problem, if I live here and I want to go there, where do I live? And you have all the main issues of modeling that ETH is very good at, okay? Transport modeling, land use, rent. How are you then going to incorporate all the problems of the demographics, of the networks, within your modeling framework of where you live, where you work, and what is your access to opportunities, okay? So the main issue here is that if we want, for example, to look at inequality, we need to think about opportunities. Are we leading as well without even thinking about the sort of differentiation between skills and ethnic and so forth? We need to think about the opportunities that are going to be given in terms of where you live and where you work. The next bit, of course, is one of the main issues that maybe here in Singapore, because you have the one city-state, is not as relevant as in other different places with respect to the size of the city. Nevertheless, you can think about, instead of the size of the city, the size of the differentiated communities that are around. Is bigger better? And how are you going to be measuring these sort of things? So I bring this because the center is very familiar with scaling laws and so forth, and I'm going to be touching upon that, and what does it mean? And how do you really look at increasing returns in this context? Then, of course, is why does the city look the way it looks? Morphology. Does it matter how morphology affects the space, how the space then affects the economic activity, and so forth? So this point here, I will be talking more about during the Congress. And finally, evolution and change. So one of the main importance within complexity science is that we say, my city is unique, my country is unique, because we come from a history, a trajectory that led us to where we are. Nevertheless, can we extract generic patterns from all of these different trajectories everywhere? Can we then be able to model something out of all these different trajectories? So this is the main quest of complexity science. In spite of being very differentiated and having many different trajectories, we can still detect generic patterns that are modeled in the same way everywhere, okay? So of course, which are these generic and how generic they are is the main quest of what we're trying to understand, and how the particularities of the systems intervene and how we can incorporate that in order to be able to do these models. So first, I'm going to start with what is a complex system. So I started this lecture in this way, but maybe everybody here is aware of complexity science. Are you all within the complexity science framework? So maybe not. So what is complexity science? So you have a system that is composed of many interactive components, okay? Which means, for example, we have people going from one place to another, you have transport, you have education, you have all sorts of things, okay? Or even just people, right? You have people. One person is not a society, okay? You need all the different set of persons to form communities. And a society is a set of different communities coming together. So one individual, if you were to say, okay, I'm going to explore a society, and I take just one individual, and I study the trajectory of this individual, where the individual was born, where the individual studied, how the individual came to meet its partner, how do they have children, I won't be able to explain what a society is, even if I know every single detail and all the DNA of that person. In order to be able to understand society, I need to understand how this individual interacts with all the other individuals, and not only with the other individuals, but with its environment as well. And how then the environment changes the individual, because the individual is also changed by the interactions, and the environment is changed by the individual and the interactions and so forth. So one very important thing is then that what you have is an emergent behavior that is unique to the whole system, and it is very different to the single interacting component, okay? So this is the main thing of what a complex system is. You have an emergent behavior that cannot be modeled by modeling one unique interacting bit. You need all the interacting bits, and once you know how they're interacting, they feed back into the environment changes, and so forth. So you have a loop that is constantly changing, okay? So this is the crucial bit of complexity science. And so of course you start to think about how, in terms of cities, you cannot have only looking at one specific aspect without seeing how this aspect is going to affect all the other ones. So if you're going to be looking at changing transport, how then the movement of these individuals are going to be changing whatever is going to be happening. If you're going to put new jobs somewhere or new housing places and you're going to gentrify the space, what's going to happen with the people? How the population is going to live? So you see how you're all very familiar with this idea of complexity science, and so, because intrinsically that's the way we live about. But of course, what is very difficult is to be able to model what is the relationship between all these different parts, because each of these parts is a complex system on its own, and then interacting with all the other system is very difficult then to be able to manage. Okay? So for example, this is one of the emergent patterns that nobody thinks about, okay? Because of course, why it's a complex system, because even though you can drive the system, you won't be able to predict that you are going to be forming these patterns, right? I apologize for the slides. I don't know why they're so elongated and a bit blurry. Anyway, so for example, the stock market. If we were able to predict the stock market, it wouldn't be working in such a way, okay? And we have crashes and we have all that. But if you think about it, the stock market is a consequence of each of us interacting with the system and the firms and so forth. So we are creating this beast that then we don't know how to control, okay? So this is a bit where we're thinking about with respect to complex systems. So we have local interactions that give rise to the emergent behavior. And then, of course, we can then drive the complex systems by changing the local interactions. But the main important thing is that the big picture shouldn't be missed, okay? Because I think most of the time this is what's happening. We're focusing too much on how to change the local interactions in order to change the emergent behavior, missing sight of the global picture. So, coming back to the question, what are then the generic patterns that can be observed in all systems of cities, despite the different trajectories? So if we think about it, we have Zipf's law, which of course doesn't apply to Singapore. So Zipf's law tells you that if you look at countries, and you look the size of the country, of the different cities within a country, you will realize that for the largest cities being, like the size X, the second largest one will be half of the size of the largest one. The third largest one will be 1/3 of the size of the larger ones, and so forth. So you have this regularity that applies everywhere around the world, even though cities are growing and shrinking at different rates, okay? So you have this regularity that in spite of the different wars, trajectories, socio-economical problems, and everything that is going on, you have a fluctuation, of course, around the law, because you have to think about in terms of statistical means. You still have a law that you can observe everywhere, which is quite, quite something. You have the law of proportional growth, which is Gibrat's law. And that's also something that you can find in firms and so forth. So firms everywhere in the world, you will see growing according to this law in the same way as laws. Then you have economies of scales and increasing returns. So we're going to talk about scaling laws at the end of this talk if we have time. The one important thing is that you observe that there is an agglomeration of economic activities that are going to produce more than expected according to the size, okay? And you also observe, this is for me something amazing, because if you think about everywhere in the world, nobody's thinking in terms of urban planning, right? I'm going to be building this road in order to make the fractal dimension, optimized in this way when you're building a road. In many different countries, you will see gridded and roads, you will see, like more organic ways of growth, and the patterns that you observe are fractals. Inside of you, you have fractals everywhere, in your eyes, in your lungs, and so forth. And we are constructing fractals, being built out of fractals without even realizing it. So this is something that I'm not going to be talking about today, but it's something quite important, because it's this self-similarity that goes about from the very small scale to the bigger scale. And then something that comes out of the interactions that we have at the very local level, and many different ones, we end up with a hierarchical structure. So we end up with a hierarchical structure that I'm not talking about a managerial hierarchical structure. I'm talking a hierarchical structure of how one thing is contained into another, which is contained into another one, which is what I will be talking about mainly today. The hierarchical structure of things and the scaling laws. So of course, this is a more generic motivation of why it's important to look at cities in terms of complex systems, but I don't have time to talk about all these things. I'm just going to be focusing mainly on the hierarchical structure and on the scaling laws. So the main thing with respect to the hierarchical structure is that there is no unique hierarchical structure. It really depends on what is the problem at hand that you're talking about, okay? So I'm going to start looking at how can you detect a hierarchical structure in a system if you don't have much data, right? So for example, nowadays, if you think about a hierarchical structure in a managerial way, you will be able to kind of draw a tree with respect to who responds to whom and so forth. But if you have a structure in the past, or if you have something that you're not exactly, you want to understand how it works, how would you be able to detect this hierarchical structure? So I'm going to be focusing on communities, on urban systems today. So if we think about communities, why do communities form? Why do we have settlements forming? So of course, you can think about interactions. You're going to come together in order to have division of labor. You're going to interact with the other community in order to be able to trade of skills, trade of goods, and so forth. So if we don't have data about these things, is distance a good proxy for this kind of interactions? And once we define that, then we think about cities, and when we're trying to draw the boundaries of cities, are we talking of cities with respect to the people? Are we talking of cities with respect to infrastructure? And we're going to see how these two come together, or don't necessarily always come together. And so today, I'm going to take you back in time to 1086. So basically, this is an extremely interesting data set, because when William the Conqueror came to the UK, he said, well, to England, he said, okay, I want to be able to know what is it that the people have in order to be able to tax them, right? So he conducted the first census in Europe in order to be able to tax individuals, okay? And of course, this is work done with the people from the archaeological department, because otherwise I wouldn't be able to work into that. So this is the way that the data looks like, which is absolutely horrific for the people that do data science, okay? And so what is it that they did? So you see you have the vils, which are the places which have this data. And the main important thing is that what you have, and this is important for what we'll be following, you have these points, which are the meeting places. Okay, so you will see all this juncture, you will have all these little paths coming into the one place, the meeting place, in order to take decisions about many different issues of the community and so forth, okay? And so what these people did in the archaeological department is to be able to geolocalize all these vils, okay? So they took this huge book and they were able to put in the space where these places were. And this is the way the data looks like. So we're going to say, okay, and so what? What is the main issue with that? The main issue with that is that we're talking about the 11th century, where people didn't know exactly how was the hierarchical organization of the space, okay? And in particular, because you have many different issues, so you can see more information, with respect to how the Anglo-Saxon assemblies work, okay? You will have many reshuffling of the space with respect to how the space was conquered by different set of peoples and so forth. But more importantly, what you have is that you have data from the 19th century that then is tried to put into the 11th century. So you have an understanding of the 19th century space that you want to integrate into the 11th century. And so of course, when they came to see me, the main issue is that it kind of doesn't make sense to be using an organization of the space that dates from the 19th century in order to be able to understand 11th century's England. In particular, because what you have is different chronologies that come and sit together, okay? So you don't have the one realization in which you can say, for example, oh, this is England, and you know, like we're all happy here. You have many different things coming into place that will make a reshuffling and an organization of the space. So how can you make sense of all these different organizations? And so what we decided to do is to say, in particular, back in the day, we're going to consider that space, the distance between settlements, is the main important characteristics that is going to tell you how these communities used to be organized back in the day. So how are we integrating that space back into the administrative and organizational structure of the space? So we're going to run a model that is a model of percolation that basically tells you if I'm passing a message to somebody else, I'm going to spread this message to the closest person, okay? So for example, in this room, you will have that this message will be very easily spread among all the people sitting here and among all the people sitting there and sitting there, but not between you, because there is a corridor in between. And you will have to get up and tell the person what's going on, and you will be interrupting the lecture, so to speak. Yes? And so you will have a message that can be spread very easily within a community that is in close proximity, okay? Or if you were infected by a disease, you will be able to pass this disease to the person closest to you, depending on the intensity, but not to the person that is further away. Yes? So in this sense, all of you will get infected, but not the other ones, or only all of you. Yes? So this is more or less the idea. If we think about communities back in the day, the way trade will be made will be done by proximity. And let's see, of course, you know, how it works. So this model is mainly used for spread of fires. So if you have a tree that is on fire, then it will spread to the other trees according to its proximity. So if we think about these points in the space, then you have all these points, and the message is going to spread to the closest neighbor. But once the red one spreads the message to the neighbor in blue, the neighbor in blue will be able to spread the message to the other closest neighbors, and so forth, until all the closest ones are able to be reached by the message, but you will see that there will be some that will be left out, okay? So of course, one important question here is that, okay, I understand the spread of the message, and I understand the spread of a disease, because you know how long a virus can survive, you know, in an airborne disease and so forth. But in your case, Elsa, you're using this distance. What is this distance? What does this distance mean? Which distance are you going to take for the villages back in the day, right? This is the main question. Is there a universal distance? So would you take one? And so, of course, the question is very difficult, because it depends on the sort of interaction that you're talking about, the sort of distance that you will be given. Nevertheless, of course, one considers back in the day, there were no cars, there were no trains, and of course, the distance will be much more restricted, yes? But of course, in order to get rid of this problem, we're going to explore this with many different distances, okay? We're not going to set the resolution at the single one, but we're going to see what happened when we change this distance, and whether any patterns emerge. So basically, in this sense, our views, our points that unfortunately, this is a map that is supposed to have dots, even though it's all blurry in this thing, but it's supposed to have all these points here. And so the points, you can see them corresponding to the trees. And the way we're going to look at this, so you can look at it in two ways. Either you're spreading the disease, you know, in a very small interval, or you think, okay, if the disease was huge, if the fire is huge, what is it that I can do in order to make the communities, right? So what does it mean? In order, where is it that I have to put the trees that are on fire, which are the ones that I need first to put down in order to avoid for the whole forest to burn, okay? So this is the first principle. And so in one way you can think about, if I have my whole fire coming here, I'm going to be cutting the links that are the weakest ones, okay? In this sense, the distances that are the largest ones. And I'm going to start, say, for 5 kilometers, 2 kilometers, and so forth, and see what happens. So when I do this, let's see if it works. Yeah. So when I do this, in red, I have my largest connected component, so this is my whole thing on fire. And then you can see how specific communities start appearing as I start reducing the distance. So what I'm saying basically is, you cannot walk 5 kilometers. You're only going to be able to walk 3 kilometers or 2 kilometers, and this is what happens. The small communities start forming. But overall, with this exercise, what you can observe, which is the main thing of this methodology, is that there are different configurations that are different from one another that emerge, okay? So I have my different configurations depending on how do I allow people to walk, okay? So how much can the people go around in order to interact to the next community, okay? And I will have different configurations. And so the main thing to consider is that when I do this exercise, I'm not looking for the one single configuration that will be able to encompass everything, because remember, it's a set of histories and palimpsests that come about, okay? So it won't be one configuration, but it will be a set of different configurations that will give me some insight. So for example, if I look at this distance, and I look at what was going on in the 8th and 9th century, well, you cannot see much with this slide. But you have Mercia right here in the middle, which is what you have here, okay? Let me see if with the other slides. Then you have a big reshuffling, you know? So this is the main thing that I was telling you about. You have all the Vikings, the Danes coming into place, and so the space was reshuffled in many different instances, okay? So this is the 9th century. And then we can see the reshuffling of many different things taking place. But you can recover East Anglia, you have East Anglia, you have Mercia here in the middle, you have Wessex, and you have Northumbria. So somehow, just by looking at the way you have the distribution of villages, you can make sense of some sort of organization that was taking place back in the 11th century. And you see, this organization is very different to the one that was understood from the 19th one. So here you can see it more clear, Mercia, East Anglia, Kent, and so forth. So going back into Dane's law and the organization of the 19th century. So this is what is used in order to understand 11th century England. And you can see that there is something that can be said with respect to people living here, but it's not entirely right. Okay, and so this is why, whether this is right or this is wrong, of course, one needs to think about. Okay, and one needs to go into more details with respect to the types of things that were found in all these different places. But the main thing is that, at least in the way the configuration of the space was given, it is quite different to the way it's understood from the 19th century. And of course, if you have read The Hobbit, you will know that there were also shires organized back in the day. And at a different distance, you can recover some of these ones, okay? So the boundaries that I'm putting here in black are the boundaries for the shires back in the day. And so you can see that the methodology, in a way, gives you as well these delimitations of the shires. So what is this thing saying? It is saying that the distance was absolutely essential in order to be able to see whether there was interactions between the people back in the day. And one can recover some of these ways of thinking about boundaries just by looking at the interactions between individuals. That, of course, we're using only distance as a proxy. We don't know what are the real interactions there. And talking about trajectories and dependencies in the space, then you can see how, from the 11th century's data with respect to the sum of holdings and 2013 data, you can see that the patterns are not that changed, okay? And this is something that is quite surprising. Right, so we know more or less that distance is something important, you know, for the settlements of the day. Of course, something to keep in mind is the geographical constraints. So England is quite flat, so you will need then to consider the distance with respect to geographical accidents such as mountains, rivers, and so forth, in order to be able to go into more detail. But if we think about the 11th century, we think, okay, so maybe actually we're beyond this embeddedness in the space. Are we or aren't we? So what about 11th century's world? So can we still take distance as something that is important for our 21st century world? In particular, if we take the proxy for urbanization, that is one of the main things, which is street networks, because if we think about what we're talking about this meeting place in which many different paths will come together in order for individuals to meet. If we think about the street network, we can think of it in the same way. Oh, I don't have it in this one. So we can think about it in the same way. You will have street intersections that will be the outcome of this process of having to connect one place to another one, okay? So if we think about the street intersections now as our trees that are on fire, and then the message will be spread, what will be happening? Is it still relevant? So if we take OpenStreetMap, are you familiar with OpenStreetMap? Yes, so basically it's like a Wikipedia but for streets. You put the streets, and there is a big effort of taking as well satellite maps in order to be able to map these things. And I'm showing this work that was mainly developed by Thomas Russell, a master's student at CASA in the MSc. So if we look at the street network and we think about distance, this is what happens. So what is the first problem going on in this simulation? So the first problem, of course, is that we need to consider why is it this darker than these other places? It's not because in these other places there are not streets. It's also because you have to think that this is like a Wikipedia for streets, which means that it will be biased according to the effort that is done in order to map one place as opposed to mapping another place, okay? So this is extremely important. So one needs to think about as well the biases in the data. And this is where we go back to the idea of the distances and the palimpsest. It's not at one specific distance that you will have a full configuration, but within the same effort and within the same country, what are the messages that you can find? So this is an example of some of the biases that are going on. So for example, for the same kind of street networks, you will have a very different effort from one to the other year, from 2011 to 2016, according to the effort of the intensity of the data that is introduced. And so of course, you think about, well, is a pattern that we observe in the street networks telling us something about the densification of the space with respect to the population? And so in order to look at these kind of things, we look at data, model data of how population is, has evolved in the world. And then we have some insights of the correlation between the two. So this is model population, and then you can see that some of the patterns are still there with respect to the intensification of the street network. Okay, so we're talking here about the generic set of streets and so forth. But what about the regions? So if we look now at doing the same process but putting the same colors as we put before, no, sorry, not the same colors, but we just distinguish between the colors of the clusters, this is what we observe. So depending on the distance, you will see different clusters coming together, and they will be differentiated for different colors that are selected more or less at random in this case. And so of course what's going on is that there is less intensity of data, okay? We cannot say that of streets, but of data being led there in other places. And the outcome of this exercise is the following. So one observes Brittany, one observes the rest of Germany. We have this bit that I will be talking about tomorrow, of a divide in the UK between the north and the south. And then we have the Alps and so forth. And more interesting, so for me, I'm more familiar with this space here. So this is part of Spain. So all of this is Spain. This is part of Spain, which is Galicia, and this is Portugal, okay? The language spoken in Galicia is much more similar to the language spoken in Portugal than to the language spoken than Spanish in the rest of Spain. So you have some sort of relationship between languages and the way the communities have formed back in the day. Here, you have a division of 3 different clusters, which you will be quite familiar with this one trying to get its independence from the rest and so forth, okay? So somehow, the way, here we have to remember, what is it that I'm plotting here? I'm plotting clusters based only on the intensity of the street network. There isn't anything else into this data set. All that I'm saying is that this is what you obtain out of looking at infrastructure. So somehow, infrastructure is giving you a differentiation between the different spaces, okay? So somehow, you have Catalonia, Valencia, and Murcia being different in the way you can think about, well, it's not that crazy, right? So the local government will be investing more into its road infrastructure in one place and another one and so forth, and maybe this is what leads to differentiation. If we continue to look at other details, then you have the Balkans and Kosovo and other places that are differentiated as well from one to the other one. Of course, we have to go back and think about natural boundaries. If you have a place surrounded by mountains, it will be more likely to be constructed as a unique community, differentiated from another. And if we continue to look closely at it, you have Ukraine. Then you have this cluster here, this orange one that appears, that corresponds to these 3, well, it doesn't correspond. It has all these 3 cities that have been in the news when the Ukraine war started. If you look closely, you will see that you don't have a river crossing like that, but you have something crossing like this, okay? So somehow, if you think about what is the control area nowadays, it exactly corresponds to this one that we detected with the road network. So somehow, there was some sort of community existed in terms of the morphological space, in terms of the way the structure of the street network was laid out, that was differentiated these ones from these other ones, okay? So this kind gives a sense of how we can then look into what is going on in order to see what is the relationship between the people living here and the people living here and the relation between the two. Of course, recently in the news, you saw that people are quite distressed by this division, and people are dying in queues in order to be able to access one place and another one. But it makes you think about how this came to happen, right? And by looking at things of this sort, in which here you have a very slow dynamics of having just infrastructure taking place, and here you have people moving from one place to another. So is there something that we can do in order to have more integration and less segregated space? Because in a way, this is showing you some sort of segregation that was going on and allow for something like this to happen. Maybe it's a very strong thing to say, but it's something worth investigating. Was there segregation? Could this have been prevented in some way or another? And all of this to say, then going back to the last bit of the lecture, that I'll go very quickly, is we're doing this exercise of wanting to understand the hierarchical structure of the space and the boundaries in order to go back to what we were saying at the beginning, the measurements that you're going to be making of your system, do they or don't they depend very strongly on the boundaries that you're drawing? If I'm considering a city, is it the same to consider the city than the metropolitan area? Do we need to look at neighborhoods instead of cities for certain processes to develop, and then to see how these neighborhoods interact with each other, but as entities? Or are we going to consider everything the same? So more or less, this is the quest of the next part. And because many people here are familiar with these urban scaling laws, I'm going to be taking this as an example. So I'm going to run very quickly into what are these urban scaling laws in order to motivate what are we talking about. Which, like thinking about it for Singapore, you will need to think about it in time, since you have the city-state instead of the many different cities coming into place. So, Kleiber's law, Kleiber discovered that if you look at the metabolic system, at the metabolic rate of animals, you find this amazing thing, which is that if you know exactly what the mass of an animal is, you're more or less able to predict how much it needs to eat. But moreover, a bigger animal, a bigger mammal, is more efficient in the way it consumes food than a smaller ones. So a small animal such as a mouse, it will have a heartbeat very quickly, and will eat a lot, and will have a lifespan very short, compared to a big whale that won't need as much food as the small animals, and will have a lifespan longer than this one. So what it means is that if you look at the metabolic rate, it will scale to its mass in this way. So this exponent here is less than 1, which means that it's less than proportional. Okay? So the bigger the animal, the less food it needs. If it was a 1, if you double the size, it will just need double the amount of food. Okay? If it was 1. Because it's less than 1, it needs less food if you double the size, less than twice the amount of food. And so, what you came to realize is that if you know everything about a little mouse, you're able to predict everything about the elephant. Okay? So this is very much what inspired the people at the Santa Fe Institute to think about cities in this way. So, if you know everything about a little town, can you know everything about a big city? That's the main thing that is behind. So, and this is a book that was recently published by Geoffrey that you can read with respect to how things scale with the size. And so basically, what you will see is that in cities, what was in this paper, what was presented there, is that you will see that there are things. If you double the size of a city and you have a certain number of houses, you will need double the size of the houses. You won't need more houses because you have just, everybody needs a house and not 2 houses. In general, I'm talking about households and not secondary houses. But if you come together in a city, the bigger city, you want to save on things. You want to save on services. You're not going to have 1 school per child. You want to capture in a school as many children as you want, okay? So this will be a bit like the metabolic rate. You want to save on infrastructure. You want to save on services. So you're going to come together in order to save on that as the same as saving in food for the big elephant, okay? So that will be the sublinear regime, economies of scale. But then, here is a thing that really passionate Geoffrey about, which is increasing returns. If you come together, then you're able to produce more wealth, but also more crime, okay? So it is interactions that in principle gives rise to this extra productivity than expected according to the size, okay? What does it mean? It means that a bigger city, if you double the size of a city, you will have more than double the productivity, okay? And so, in one way, one thinks, are bigger cities better? So of course, one needs to think about these other things, such as crime, and what about inequality, and all these other things. So one needs to keep in mind as well the heterogeneities that go inside these kind of things. So I'm doing this plot because I think this is a nice way to be able to visualize. What you have here in the y-axis is the exponent, referring to this one here. So red means that you do much more than expected, so it's above the line, above the 1. Green means that is proportional, okay? And blue means like the metabolic rate you're saving on these kind of things. And here I'm just reproducing the results from the PNS paper. And one needs to take into account this paper was initiated by Denise Pumin, actually, in 2004 when she visited the Santa Fe Institute. And she was already thinking about these things happen, the way you're going to have increasing returns has to do also with respect to the maturity of the industry that you're talking about. So we're talking about productivity if you double the size of the city, but one needs to step back 1 second and think about the productivity of what? If we're talking about a country that is started into the manufacturing industry and is just a new thing, it's going to be behaving according to this more than productive, right? But once it reaches its maturity or its decay, it's not going to be more than productive, okay? So one needs to think about the maturity of the industry one is talking about. So this is something to consider with respect to scaling laws that Denise Pumin very much discusses. In addition, the speed of transportation. So we were talking about, when one thinks about these scaling laws, you're talking about what is inside a city, but what about the interactions that take place within a city and between a city? How the speed of transportation plays a crucial role with respect to the communities that we're talking about, okay? So this is something that she also discusses. And she also talks about the sensitivity of the measuring to the boundaries. So here think about cities and metropolitan areas. So if you're going to be talking about things that have to do with economic activity, you have to think about the people that come from far away, commute to work, and then bring all this wealth back to their places of their households and so forth. So the city is no longer only the place where they earn, but also the place where they spend and so forth, okay? The skills, where do you think about the skills? How then are you going to put transport into place in order to be able to then reach all the people that need to commute to work? And so what we did as an exercise here for the last few minutes, so we explore these scaling laws, considering cities and metropolitan areas, considering cities from the urban cores to the different extents, and considering metropolitan areas in terms of commuting to work areas. Okay, so of course there are many different ways to think about metropolitan areas. We experimented with people commuting to work. So how did we do that? So if you think about the urban space, how do you define cities? So this is one of the main issues. In order to then do an experiment of how to define cities, we consider the density of the population. If you look at the density of the population here in the y-axis, so you can see London is much denser than the others, you can think about, then you say, okay, this population density is given according to the census units, and then you can think that, okay, I don't know what happened there, okay, but I think it's still there. Well, you can think about building your cities if you did transversal cuts. If you do a cut very high up, the only point that is going to survive is London. And then as you go down, you will be able to include more and more cities. And then if you go really, really low, you should be including everything. So it will be something, this is so unhappy with this. Let me see. It will be something, is it working? Yeah, I think it's working. It will be something like that. I apologize for the maps. They look neat in the computer here. So you can see if I take very high threshold for the density, I will have London, but I almost don't have any other city, okay? As I start to relax the density, then this starts to expand and to include more cities up until the point that you have a mesh So here you have cities still, until the point that you have a mesh of many cities coming together. And so the question is, does it matter? Because maybe I like this one because I want to say that all the cities in the north are one thing, okay? But maybe not. But the whole idea is that when you're going to produce your indices for your cities, you want to know whether it matters or it doesn't matter. And when is the difference and why there is a difference between the two. And so after you do this exercise, then you want to include the commuters, because here was only density. I was only talking about the extent of the density. So how many commuters I'm going to include, right? So this is the next question. And so we did the same exercise in which we're going to be including different percentages of commuters. So here you have your regional clusters of urban cores, and in light blue, you have the commuters thresholds. So it's the same principle. You can start with a few commuters adding areas if a few people commute, up to the point that you exaggerate and you end up adding everything. Yes? But the question is, where do you stop? And whether it matters, okay? So one needs to be very clear about what is it that you're measuring and whether it matters or it doesn't matter. So by doing this exercise, I'm just going to show you a couple more slides. If we take, say, 30% commuters at the definition of cities, that today I'm not going to go into detail how it is constructed, you can see that is flat line. What does it mean? I wanted my red ones to be above 1, and I only have a few. And I wanted my blue ones to be below 1, and I have some that go up. Okay? So which one do I take? So what I'm trying to say here is that for a definition with commuters, things such as area of green space don't make any sense, okay? Because these are related to the things that are urbanized, okay? So you cannot then start to add things all around in order to think about the areas of green space, because these don't belong any longer to the main cores of cities. While it works at least for some people employing financial intermediation. But other than that, it's flat line. And what is going on? Okay, so Jeffrey was like appalled. Flat line of the UK with good reason, right? So what is going on? So let us look into more detail as one of the variables. Innovation, that more or less is most of the time, it is, patents are considered the proxy for innovation, as bad as they can be. Let's look at the following. For a definition of the urban cores, okay, without taking into account commuters, I do have my exponent bigger than 1. Oof, I'm happy with my exponent bigger than 1. And I have a population threshold of 10,000 people. What does it mean? I'm only taking cities that are larger than 10,001. On the other hand, if I say, well, I only want the cities that are larger than 50,000 people, which is not crazy, right? I mean, populations of 50, most of the time you will hear 100,000 people, okay? Population of 50,000 people. I take this threshold, and my exponent is no longer bigger than 1. It's 1, flatland, okay? What is going on? If you look here, you have your outliers, okay? Cambridge, all these places here are in a belt where you have the headquarters, because patents, of course, are put back into the headquarters. That's where they're registered. And because it's so expensive to be in London, they will be in all these belts where they are, okay? And what else is happening? When you get rid of all these ones, okay, so the smaller ones, the small cities that don't have patents, don't have many, they're pushing the slope this way, yeah? They're pushing it higher. When you get rid of all these little ones, then they go back to linear, okay? And so then, when you're talking about bigger cities being more innovative, what do you mean? Which bigger cities, you know? What set of cities I'm going to put into my model? This is not valid any longer if I only take the 50,000 bigger, the ones with 50,000 people. So one needs to be very careful with respect to policy when you're thinking about models of cities that apply, that are universal, okay? They're not universal, one needs to be very careful about which ones. And then the important thing is the outliers here, okay? What's going on here? It's not that Cambridge is very big, it's just that it's a university that has many firms there and many patents coming out of the startups. Okay, so going back to the idea of trajectory and history is very, very important. So you cannot take one out of the other one. You cannot look at all these scaling laws with only the one number without considering what is going on inside, okay? In addition to the boundaries, not only the boundaries, but also what sets of cities are defined within your system. And once you include the commuters, you have the same problem. And I think my time is up. And so if any of you want to explore this business of scaling laws, this is an essential paper that cannot be missed for anybody looking at scaling laws, okay? Otherwise, the paper won't be accepted. So what this paper is, and it's not mine, okay? So this publicity, this is publicity for this paper. So what did these people say? They say, it's so weird that all this business of the scaling exponent changing according to the city boundaries, that there must be something more into it, okay? And so what they explore is to try to say, can really this urban indicator be the outcome of being more productive if you're part of a bigger city? And so they explore really to see whether the power law is a valid thing in order to be able to model the space. So this is a very nice paper. Okay, so to conclude, it is very interesting to look that now in our contemporary world, one can still think about our communities and our identities being traced back in time in the way we have left our footprints of the communities forming. So we cannot get ourselves out of the space and believe that we live in this cyber world uniquely, because we're very much dependent on the sort of environment and we fit back into it again. So in a way, street networks, kind of give you a peek into history, okay? How things have evolved and how communities are differentiated one from another one. And mainly, as well, this idea of the hierarchical organization of the space. So today I show you a simple mechanism in which you're looking at the street network, you're looking at the embeddedness of the space in order to be able to take out the hierarchical structure of the administrative boundaries. But if you think about any other kind of hierarchical structure, so for example, in terms of economic activity and so forth, it's just a matter of getting your network constructed according to the relationship that you're talking about, okay? So for the same system, for the same villages, if you think about the sort of trade that there was between them, you construct, instead of a distance, you put something else, and you will be able to get out a different kind of hierarchical structure. And of course, none of this will be possible without the collaboration of all these people. So something that I'm very, very much appreciative about. So I'm a physicist by training. Nevertheless, the only way to make sense of all this model is by collaborating with geographers, with computer scientists, and with the archaeologists, of course, and Mike, that is like everything in one unique thing. So the only way to understand complexity science is to collaborate with people, because from your single discipline, you won't be able to grasp the whole thing that you're talking about. You have to interact and get out, or make sense of what you're observing, collaborating with others. Thank you.
Thank you, Dr. Elsa, for sharing on the importance of looking at local interactions and street networks to uncover patterns beyond the demarcated administrative boundaries. We would like to request for Dr. Elsa to remain on stage and invite our moderator, Zhongwen, on stage for the panel discussion and Q&A. If you have a question, please proceed to the standing mic and state your name and organization after the panel discussion.
Hello?
So I think I'll say something, give Elsa a few moments to catch her breath. I think this morning session, I believe there are many questions from the floor, because firstly, I think this topic in itself is quite niche, and yet many of you have turned up. So I'm sure many of you have a lot of burning questions for Elsa. Thank you, Elsa. Yeah. So I will intend to do two parts. I will start with a few thoughts that came to my mind from hearing Elsa's talk this morning, as well as looking through quite a lot of work that Elsa has done over the many years. And then I'll open up to the floor to look at what are some of the perspective and questions everyone have. So the power of the collective. So I will start with the first question. So I think what Elsa mentioned earlier about bringing us back to history, looking at England during the Anglo-Saxon periods. Maybe I want to start first with looking back at Elsa's own history. So yourself being a theoretical physicist and moving into the urban complexity space. So I wanted to ask, from looking at what you studied earlier, looking at the particles, looking at ants, colonies, to now looking at cities, looking at communities, looking at firms. What do you see as similar between what you had looked at earlier, now? What do you see as different? And hence, what are your thoughts in terms of the use of tools from theoretical physics in looking at cities? So what do you think are similar, what do you think are different, and what does it mean when we are using some of these techniques and tools from different disciplines?
Okay, thank you very much. So the main thing that I see as similar is the fact that what I was talking about at the beginning, that when you're trying to explain the system, if you only take one component and look at the component very, very deeply, like for example, if you look at the particle moving and you wanted to extract the temperature, it will be impossible from just looking at one particle moving. You will need all the set of particles coming together, interacting, in order to be able to make temperature, right? So you don't have one, you need all of them coming together. And so when you look at ant colonies, it's the same as when you look at, though it's not the same, of course, but what I'm trying to link back into one another is that by looking at one individual, looking at one ant, you won't be able to really understand the system. So we're talking about ant colonies. We're not talking about ants, right? So we're talking about a social system. We're not talking about one human. So even though every human matters in whatever we're going to be doing, and we shouldn't be leaving anybody behind, which is something very important that when we think about these systems, when this thing that I presented here is an aggregated, so the measure is an aggregated at the city level, but what's going on in the city? I didn't talk about that here, okay? Which is something really, really essential, because we're leaving that behind. We're leaving the heterogeneities behind, which we shouldn't, right? So we want to have our city that is performing very well, but we want all our individuals not to be left behind, because some of them are doing very well. So for me, it's the idea of really thinking about a system and a systems between systems more than an individual ingredient. Okay, so that's what I see in common in all these complex systems.
So is there anything you feel that is starkly different?
Oh yes, and also you asked me about physics. So of course, when you say you're a physicist and come to talk about things that relate to social sciences and so forth, everybody thinks about deterministic physics and Newtonian mechanics. And they forget about, which is very important, they forget about the main thing that happened more than 100 years ago, which is quantum mechanics and so forth. Everything is probabilistic. It's not deterministic. Okay, so that's the first important thing to set aside. And in a complex system, this is more or less what you have. You don't have a way to predict exactly what will happen. Okay, you have a set of probabilities that are out there. And so in physics, we have been thinking about all these set of probabilities in statistical mechanics for a very long time. So to think about a complex system in terms of a set of probabilities and how to drive it, and knowing how a chaotic system, if you change something, it can go all the way to a different place, is something very important, which is very opposed to what a deterministic system is. So thinking about complex systems in terms of physics, physics coming into place in order to think about complexity science is something that has been going on for a very long time, and also in biology. So you have life, for example. If you wanted to explain life out of just looking at one cell, you wouldn't be able to do that, right? So how life on itself is an emergent behavior. So these are all the commonalities that I see. And so in physics, we try to make sense of this emergent thing that you wouldn't be able to explain by looking at one individual thing. And we have tools that we have been using for that, and also in ecological systems, which is very interesting. So I think now we also need to bring ecological systems into urban sciences, because they have this insight into what is going on at all these different levels as well.
So maybe if I extend what Elsa just shared earlier, if I ask one more level. I mean, what you mentioned about how we look at this identifying communities, right? And in terms of what are the kind of measures or indicators we should be looking at, my takeaway seems to be asking ourselves what connects these different entities, as well as what separates these different entities. And you mentioned about how if we look at the road networks, we look at the densities, in some sense there's a connection between people and infrastructure. So with current technologies, especially with the use of advanced communication technologies, in the social media platforms, the way digital economy is evolving, what do you think are the new kind of connectors or separators that we should be thinking about as well, in thinking about how communities are formed, both physical as well as digital or virtual type of communities?
Well, right. So, so this is something very interesting, because we think about all these technologies and we think about ourselves, you know, like being beyond the physical space and being in this cyberspace and this very powerful space. Nevertheless, in the end of the day, you live in one place, your children go to school around that place, and you have to move to go to work. Not all the time, of course, you have the cyberspace as well connected. But when we think about this connectivity between individuals, it's about what differentiates them in terms of, are they all having the same opportunities? So I think about that in terms of opportunities, right? So is everybody having the same access to education? Is everybody having the same access to employment, or are we differentiated people by segregating the space in such a way that employment, so even though maybe you have transport, but where is employment, and what sort of opportunities do the people living in this area have with respect to education, and then being able later on to reach the good universities and have the employment and so forth. So I think as much as we want to extract ourselves from the physical space, it still very much matters, because, I mean, for me, education is like the principle, the main thing that needs to be very much ingrained in everything that is done. And of course, housing goes together with education, and employment opportunities and so forth, because you're going to live in a place in which you will have employment opportunities, but also you want to live in a place in which you will be able to access good schools. So everything intervenes and comes together. And with respect to the technology, so of course, when we think about smart cities and all these kind of things, depending on the country that you're on, are we doing something in order to be able that will be able to be reached by everybody, or are we only thinking about small subsets of the population? So it's something to keep in mind.
So maybe I open to the floor at this point to see if anyone has any questions that you would like to pose to Elsa. I think there are some mics on the two aisles.
So I'm Melissa. I'm an intern at the Center for Livable Cities, and I found your talk really fascinating because I hadn't been exposed to complexity sciences before this. I was wondering what the applications of, I guess, scaling laws, as well as the other thing that you were mentioning.
The percolation thing, yes.
Yes. Like, what are the applications for that for like policymakers, but also for like civil society, like people who want to engage with like cities on different levels, whether like on the government level or like as a citizen or resident?
Okay, so so they go hand in hand in one way with respect to the applications. So for example, what I wanted to show today is that when you do this process of looking at the connectivity of the space, what you can think of is that you have like the mother cluster that is England, and then it starts to separate into different ones. So what you're able to create out of that is like a tree of memberships, right? So you will have certain areas. You can separate the space, for example, in the UK, we'll be showing this tomorrow, into the wealthy ones and the less wealthy ones. And so then, in terms of applications of policy, if you're going to make an effort in order to put an implementation in a region, this region connects with which cities, you know, more than the administrative ones, because the administrative boundaries sometimes move much slower than the way people interact. So the clusters that belong to these regions are going to be able to do much better together than the ones that don't belong and try to put them together. And so tomorrow I will be showing, for example, something that happens in the UK is that they wanted to create all this region in which you have cities that are connected, but some of them are disconnected, and of course it didn't work. Because even though they're in the north, it's not about being in the north, but it's about being able to interact between each other, how the people move into the space and how the people interact with this environment. So understanding these interactions and how you can create a policy at the region that will be able to then spill over into lower settlement cities or whatever is very important. So the integration for me, thinking about, but it doesn't need to be, you know, like a country of many different cities. You have also within a city, if you're going to then think about the communities and where you're going to be implementing these policies and how this community connect to each other beyond, you know, like the street network, but how the community is identified with each other and so forth. I think it's important to create that. With respect to the policy impact of scaling laws, so one needs to be very careful there, because as you can see, the exponent can tell you, oh my goodness, bigger cities are much better, they are greener, they are more, but then on the other hand it will be, oh no, actually they are not. And so what I was trying to convey today is that the index that you will be using in order to say whether it's better or worse, you have to be very careful. Which are the cities that are taken into consideration? Which boundaries? To which system it applies? Because it's not universal and it's not something that you can just say is greener. Well, not necessarily. So that's the main idea of the application to policy. Yes.
When we were discussing earlier at the start of the lecture, I was discussing with Limin and Elsa about the work that you're going to present tomorrow regarding how you look at different communities, and therefore, as a result, what you studied at the time was the general elections in UK in 2015, right? And it created quite an interesting set of results that I think mirrored quite closely the end result that came out from the general elections. And I think people who are interested to find out more, I think you will hear more tomorrow morning. So I was told not to steal the thunder. So maybe are there other questions as well that other members have? Or at the back? I think you turn it on.
Yeah, that's a very, very important question. So yes, we have to be very aware of that, right? So correlation doesn't imply causality, and it is very, very difficult to tease out what is the thing that has that will be able to change things, especially because as much as we want to create a laboratory of cities, you know, in which we try to see we're only able to do this for the boundaries, but we cannot experiment and then, you know, change one because whatever is going to be happening in one city, you have another city is a different system altogether. So it is very, very difficult to look at causality. Very difficult, I agree with that. Yes. So one needs to be careful, yes.
Yeah. Yes.
No, it doesn't work.
Hi, my name is Bernice. So I have a disconnect in my head that I can't reconcile. So you were talking earlier about local behaviors versus emergent properties. And it's not always clear how to explain the emergent properties by looking just at the local interactions, right? So if we are interested in creating some kind of shift in a system, how do we go about it if we are trying to understand things? So if we are looking at local interactions, and then we know, oh, we cannot assume that this will explain emergent properties, then what do we do? Is it a matter of observing the system? And if so, how do you bound that system that you want to observe?
Yeah, okay. So that relates a bit the question with your previous colleague with respect to causality and correlations. So of course this is where the modeling takes place, right? And so you set up scenarios in which things can happen and try to look at the past, right? So if in the past you have a scenario that looked like that, and then you have a model that is more able to forecast what's going on now, what will happen if you change some of the variables, and then to be able to forecast a possible scenario, right? So it is related to the correlations and causality things. So only with the modeling you're able to more or less, say something about possible scenarios. But this is the main thing, right? When you're going to be changing your local interactions and bounding your system, you need to look at the sensitivity of your model to these initial conditions and the variables that you're putting in. So in the case of the cities, if you're going to change the boundaries, does it matter? It doesn't matter. If you're going to be considered certain variables, what is the sensitivity to the values that you're putting at the beginning with respect to what you're forecasting? So it is, as long as you're aware of how the system can go all the way into one direction and all the way into another, and you're aware of the sensitivity of your parameters, more or less you will be able to produce some sort of forecasting from the local interaction. So in the end, this is what you want, right? So you want to change the emergent behavior that you don't like by changing something that happens at the very local level. And you can only produce models that will be able to tell you something about the possible outcomes of this,
I wonder whether what you also meant is that, often when we think about how do we use models to inform public policy, often our focus is on the outcome, on how do we shape certain outcomes. But like you described, often these outcomes are what emerges from the interaction among different parties. So the idea perhaps is that how, if we were to test out a change in certain behaviors, how does that translate into certain outcomes? But within these outcomes, often it is also, there's different probabilities and different likelihoods. So I just wanted to, it reminded me of one of the study that I recalled you also had in looking back at Kyoto, right, looking at how Kyoto has evolved over the years in terms of its urban structure and also in terms of its economic diversity. I just wonder if we look back at, based on what was understood from the study, could it have anticipated the kind of evolution that the city undertook over the period of this that you looked at? I remember it was like 1,000 years or so, right?
Yes. So I think, for example, what we're talking about before, like being able to fit, like algorithms for what was going on in the past, and then to see how good they are predicting the present is the first initial step in order to then forecast into into the future. Of course, it's all very tricky because as I was showing today, and we have it everywhere for economic activity and so forth, there are spaces that are traditionally, something that is very different to other spaces in the same situations. So these particularities need to be also understood in order to be put as constraints into your system, because it's not everywhere that you have the same morphology and the same thing, that you will have the same things arising. So you will have some sort of generic way to model things, but you need to put all this intricacy as well into place in order to be able to say something interesting, I would say. So nowadays, of course, there are all these very powerful machine learning algorithms, as we're saying, in order to try to forecast the little details. But I think you cannot only use that without trying to construct a model and understanding beyond what it is, right? So you need to think about what does the theory, so model and theory need to go hand in hand. You cannot only fit in machine learning algorithms and expect things without having, like a theoretical framework from which you're building something, right? So I think this is the main thing not to forget, right? That you need your theoretical framework from which to construct.
I mean, I think one of the things that I always remember from, I think it was Moshe who shared with me this view, that he said all models are wrong, but some are more useful than others. And I think what you mentioned about connecting theory and modeling is certainly something important, help us understand and make sense of it. So I'm also aware of time, and I was told to time keep well. Could I ask if there's any last question? Oh, there are two questions. Okay, we take two questions together, perhaps.
Thank you. My name is Maria Boy, and I'm the president of Institute of Parks and Recreation. My former boss, Dr. Liu Taiker, estimated 10 million population for Singapore. And a lot of people are very worried because at this moment we felt that there's density in our MRT, transportation, and things like that. So how do we look at the scale? At what scale are we at if it's 10 million? How many more years so that we can prepare our transportation to be more efficient and other things?
Right. Oh, okay.
Hi, my name is Casey. I'm from CapitaLand. I just wanted to ask, since you did theoretical physics and now you're doing urban studies, has there been any insights that you draw between parallels between quantum and people in all your various studies so far?
Okay, right. So starting with the first question. So of course, you first need models of population growth in order to be able to know which are the denser places that you have to know. You have to know where people live and where people work, whether there are expectations of more jobs being implemented in different places, because you need to think about the system as flows, people flowing from one place to another, because that's how your transport then is going to be connected. So in the end of the day, you need different models that need to be coupled together in order to be able to look at the transport system, taking into account demographic growth, changes in jobs and so forth. But of course we say all this in an easy way, but we don't know what sort of new jobs are going to emerge, which sort of places are going to grow differently. Although of course you have this the government, will have these initiatives in order to put, in a strategic way, new places for different economic activities and so forth. So at present, the UK is undergoing, it's a strategy in this respect, especially now given Brexit. And so thinking, if you have a place like Manchester that used to be traditionally a manufacturing industry city, but that was long gone, like a post-industrial city, in which then one needs to think about the digital economies, the manufacturing industry in a different way to the way one thinks about clothing and so forth. And so how transport and how gentrification that has been taking place, housing developments and all that will come together in order to help economic growth. But everything is thought in terms of connectivity, of also I think this is the essential place right now with the new train as well going. How is not only the city on itself, but how the city is connected to the global, right, to the other cities and so forth. Which of course now we're in a pickle because we're cutting one of the main important sources of connectivity. And with respect to the other question, so I think more or less I answer this one of thinking of cities in terms of systems, right? So it's a system of complex systems. It's not only one, it's not only society, it's not only transport, it's not only one city, it's a system of cities at many different scales, right? So the scale at which, so then comes back the idea of the scale at which one needs to think is, we go back to this tree, right? So how affecting what neighborhood, gentrification of one neighborhood will affect the other one? Which are the main ones in which people rely on in order to then be able to see how this effect will propagate to the different, to the different scales? And so from physics, this is more or less, you know, I see urban systems much more complicated because you don't have one thing in which you can produce an experiment and measure and change it and then look into correlations and causality and all these kind of things. So I see urban systems as a much more difficult problem than you can do in experimental physics, in which you have a control, you can control, you know, your variables and produce experiments, but you can only look then at different cities and try to extract these generic things that you see over and over and over and over again. So if you see these correlations, can you then look into how to change things in order to then, you know, think about causality? I don't know. It's more or less.
I think Elsa, you mentioned a system of systems quite many times throughout this whole talk this morning. And I think one thing that I think occurs to me as part of talking about system of systems is also bringing different domains, a different understanding of different subjects together. I think one of the efforts that we've been working to in Singapore is really bringing different agencies with different domains to work together, and then also bringing faculty from different schools to come together. So you mentioned at the end, so my final question is a bit lighter. You mentioned about how you have a quite interdisciplinary team at CASA today, and Clementine is also a geographer. So what was your experience in working with people of different disciplines together? What do you think are the ingredients to make the team work?
Okay, right. So I think there is no way people can do complexity science without being in an interdisciplinary group. You know, I think there is no way one can have an understanding from a one individual discipline and think they know everything from you know, you really need the insights of I think what you need is this humble attitude of understanding that your discipline is very small compared to the whole complexity science thing. And then every one of us will bring something to this discipline, and the only way to understand it is really to interact. So I think, you know, like to being humble and to say, you know, I can only do this bit, but that's it. You know, I really need the collaboration and the insights from other people. So for example, you were talking about this thing that I will be presenting tomorrow. When we show Mike the map of the percolation and thing, he said, oh my God, these are the Tories, these are the labor. And he was the one looking at the map and being able to identify, you know, like the different voting, the different ways people vote. So of course, you know, like you need also somebody to understand the history. So also tomorrow, this north-south divide. So I come from Mexico, and I've been living in the UK for a very long time, but still, this is not my I mean, now it's my country, but you know, I wasn't born there. I don't know many things about the history. So people understanding this this intrinsic thing of the system is absolutely essential. Before I work with biologists and social scientists, so you can only have, what is interesting and very important is that you have your way of thinking about systems that as much as you think you're open is in one way. And when you bring your insights to another person that is also, you know, in one way of thinking, it is this collision of thinking about a system in a different way, just to turn around the cup and say, all right, you know, trying to break paradigms, because I think this is the main thing, you know, like you break paradigms by interacting with other people and seeing that things are not one way. They're never one way, you know. And you will never be able to explain everything because you're part of the system, you know. So trying to look at explanations from many different perspectives, I think this is the thing, you know, like, yeah.
Thank you very much, Elsa. I wanted to end initially about connections, but I think you added a better term. It's about looking at new paradigms. Yeah, and I think that's really something that this morning we all gained from this lecture, being able to not just see new connections, but also new paradigms of how we understand the city better. Yeah, I think.
Okay. Thank you
Thank
very
you,
much.
Elsa.
Thank you.
Thank you, Elsa and Zhongwen, for the lively discussion. Can we invite Mr. Khoo Teng Chai, Executive Director of CLC, on stage to present a token of appreciation to our speaker and moderator? Mr. Khoo, please.